So as you saw in the last video, this is the pin that bearing rides on, and it sits inside this recess. Basically, this bearing is responsible for keeping the back arm of the backhoe lined up with the pump, or the actual motor part of the backhoe arm that rotates, left and right. The only thing that I can think, because keep in mind that bearing was missing when I got the backhoe, and we don't know for how long, there's a good possibility that that pin might be bent or cockeyed. So at this rate, my best guess is that possibly every time I rotated from left to right, that bearing was under additional strain by being twisted. When it did let go and break, it was a small piece of concrete in comparison to the others that were already moved. So I don't think it was a load rated issue, because that piece wasn't as large as the others I had previously moved. And there didn't feel like any binding. It was a pretty smooth rotation from right to left, and all of a sudden a loud snap, and of course the machine shook. And when I looked down, half of the bearing was already ejected, and most of the ball bearings, I think all of the ball bearings, were already missing. Just by coincidence, I was able to find all the pieces, but that's not going to help me at all. So looking at the backhoe arm, it looks like everything is straight and still lined up. In my opinion, I don't think there's anything actually wrong with it. But we're going to find a solution, hopefully. As crazy as this plan may seem, I have a lot of things that I'd like to look at. I can order a new bearing. That's the hub, and that's the outer ring of the bearing right here. And this was the $453 that I spent to purchase this particular bearing, which happens to also be a John Deere part number, so that might associate some of the cost right there. I think it's 4 3/4 inch across. It's a big bearing, obviously, as you can see. I don't think that pin necessarily needs a bearing. I think we could get away with a bushing of some kind, and that might actually allow for that pin, if it is bent, if it was just a bushing, you'd have a little bit more leeway where a bearing might fracture over time, kind of like this one did. And I've got a big chunk of the actual casing that's just missing, and I haven't found it, but I'm really not too concerned at this point. I'm going to see with what I've got laying around if I can fab something that's going to work in this scenario. So bear with me a little bit, because this is going to require some hackery, but I got to at least try it just to see if it can be done. I think we have a winner. This is a rear brake drum from a late 80s Chevette. Now, the diameter of the pin is a little bit smaller than what the opening on the drum is, so the pin actually will fit through the drum. That's a good start. What I've done is I've actually marked out the only portion of the part that I would have to clearance in order to get it to fit up inside and make it kind of flush. Little bit complicated to understand, but basically I'm just going to cut this section out with the grinder, and then we're going to do some test fitting and see what we can come up with. This is going to be totally hack, but I'm going to try it just because this rotor's got cracks in it anyways. Let's see if we can find them right down in there. So this rotor's toast regardless. I couldn't even have this turned if I wanted. So it's scrap metal at this rate. It's gonna take a couple of cut-off wheels and I'll be able to make something out of it, maybe. So I'm gonna give it a try anyways and see what happens. And we'll kind of go from there and figure out what we can make out of this thing. I screwed up the first cut. I cut the wrong lines. It needed to be wider, so easy fix. Let's go see if it's gonna fit now. So the center core of the old bearing will still be used. It's jammed on there right now. And then the thought is that the old brake drum fits on top, kind of like this, and then the nut goes on the bottom pin, and this adds a bit of rigidity to the whole thing. But now the only thing I'm going to have to do is use some filler material in between the core of the bearing and the hub of the tractor and fill that void so it doesn't have the chance to move. And then this guy is basically acting as like a glorified washer that keeps the core portion of this makeshift bushing all up in position. So it looks like I might have to just adjust the backhoe's position a little bit to make this sit just right, because we're not quite centered at the moment, but I'm going to try playing with it just to test fit everything and see what we get. So this now represents the third modification. I had to kind of de-hump some spots there just to get this to sit up inside. The profile of the rear bracket, it rolls down so that disc or the drum won't fit up flush unless that's all clearanced. So I may have it close now, but out of fear of the unknown, I didn't want to cut too much material away just quite yet. Looks like it's very close. I might be able to just touch that edge up. Geez, it's hard to see with all the backlight. So it's getting there. I'm gonna tweak this a little bit more and make it fit up inside. So I was able to cut it enough to get it to fit. Now this is just the initial outer, call it an outer support cover. But what I think is going to be able to happen here is I'm going to be able to weld on the face of this brake rotor, or I'm sorry, on the face of this brake drum and plate everything to try to keep that strength up. So it kind of fits in like a keyway. All right. So I've made myself kind of a little makeshift workstation. I know it's horrible, but this is what I have. So we've got the rear drum from the Chevette that I've hacked up. It's rough right now because I just wanted to see that it would fit and test the theory of the idea. So far, this will provide bottom end coverage of this bearing. Now, I started playing with the old race, and I've got it clamped back together, so it's actually relatively smooth now. The bearing does still, you can still hear that edge in it, but what I'm proposing to do wouldn't really make that part of it anyway, wouldn't really be relevant. So what I'm thinking is to actually get the ball bearings back inside, which it can be done easily. Put them in one at a time, and then you set the core in here. I can space them out how I want them, and once they're spaced out how I want them, I'm going to try to weld inside that bearing and totally lock it up. The idea here is that this piece fits right back inside the backhoe. It's obviously broken and damaged anyway, like there's no there's no race left here. By doing that, I can essentially get the shape that I need, and then I'm going to cut out from steel some glorified washers, and they're going to allow me to weld from the core of the bearing to the outer race. So I'm essentially going to box both sides of the bearing, and I've got a few different styles of material to work with here. This would be the first and easier option. It's just a thinner sheet. It's a little bit of a heavier duty, you know, and that times a couple of layers might be sufficient for the job, and it would certainly be easier to work with a thinner material to accomplish that. I also have this plate, which is far more desirable for this operation, quite a lot thicker, and there's a lot of material available to be here. So, you know, cutting out a few of these things wouldn't be an issue, just having the appropriate tool to do so. As of this morning, I only had a couple of hole saws, which were all the wrong size, yada, yada, yada. I borrowed a plasma cutter from my dad. So my next little project here, I'm going to make a template that I can use as a guide with the plasma cutter to cut out these washer pieces I needed. And then I'm going to cut out some washer pieces and see where, how I can piece these together and how it's actually going to work. Because if I get both sides of this plated with this thicker plate steel and tied back to the core, it should give it a lot more strength, and hopefully everything's going to work out okay. All right, so the core of the bearing, and we've got our possible template here. And what I'll do is I'll trace that with the nose of the plasma cutter, and here's to hoping that that's going to end up with the appropriate diameter that we're looking for. What I will do is take the bearing brace out of the clamp, and I'm going to kind of trace it out just to see where I'm at in a size comparison perspective, because I do have to consider the offset that's required for the plasma cutter to work. I think if the tip rides, rides the edge there, I think I might be pretty darn close, but if I have to radius that edge out just to get this thing tighter, I will. I'll have to play and see. And then that is, that's not the thickest material in the world by any means, but it does have some thickness to it, so I'll probably start with the thin sheet just to cut a template and see, yes, it works, no, it doesn't work. And then I could basically make this out of metal at that point and be pretty well spot on with it. So let's keep on playing. All right, so after a few adjustments, I was able to figure out that plasma cutter a little better. And we've got a circle cut, a disc cut out of this stuff here, and it doesn't fit all that bad. It can take a little bit of bench grinding to clean up the edge, but once it's cleaned up, I'm thinking that's going to be just about perfect to do what it needs to do. It's going to need the center clearance hole cut out. That's something else I have to make another template for, but that'll be my next little attempt here, is to just make a smaller circle. Let's give it a whirl and see. All right, the wind's picking up yet again, as per usual. So I now have my second assumed template. Let's see what we can do here. I'm going to use two hands to make it a little easier. So, based on this, it's a little bit too large. So I need to try making the hole that's cut out a little smaller. Alright, so quick update. I had a piece of 3-inch stainless steel that used to be part of the exhaust on our Blazer, and I kind of traced that with the plasma cutter when I cut it out. Now this was not I had cut this hole 2 or 3 times, so it's kind of sloppy. The point is, it worked. So basically from here on out, I can cut out my outer ring, I can center it, mark where my 3-inch has to go, and then I can cut out that 3-inch kind of after the fact and make it pretty easy. So I'll use my main template to cut out the big ring, be good to go, and everything else should just kind of fall into place from there. And I can make, whether I make them out of this thinner sheet, I'd much rather use that larger plate. I think that's going to yield the best result, because that'll be a real thick piece of steel. And I'll weld up one side first, and then I'll test the bearing in both orientations to make sure that it fits appropriately, and then I can do the other half, because I think going up I might run out of a little bit of real estate quicker, so I might have to use thinner sheet on top and heavier on the bottom, which is fine with me. Regardless, I'm gonna make something happen with this. All right, break time. We will return to this in a couple of hours. Okay, so the template wooden thing, whatever, was kind of sort of working. I think this is going to yield much better results. Well, let me explain. Now, what I'm able to do is take this random scrap piece of angle iron that I had floating around, and this is, I think it's a 1024, doesn't really make a difference, because I have a 1024 drill tap combo. So basically what I do is I set this piece of angle iron on top of whatever piece of steel I'm trying to cut. So if it's the thinner sheet or the heavier piece, this will work either way. I just have to drill and tap a hole based on this screw. Then the screw gets driven in, made snug. Now, the only thing that this angle iron is able to do once it's bolted down is pivot. And have a look over on this end here, folks. Boom. So now the nozzle fits in tight. I'll put a washer underneath the angle iron, so this will keep the appropriate space. I squeeze the trigger, and I'll get a perfect circle every time. This distance represents exactly half of how wide I want to go for the cover portion. That would be the overall largest diameter circle. And then when I move the screw into this hole, this represents exactly half of that, which is, I don't know where that piece is sitting, which is exactly half of the cutout needed to clearance the large center core. So I can cut all my washers with this now. And I should be able to cut it out of large material or thin material or whatever. I'm going to do some practice cuts on the thin material first, just to see how it works. But I've got high hopes. So now the only thing you have to remember is you have to keep your center point accessible all times. So you cut the inside last, because if you cut it first, you got nothing to map the outside with. So I'm going to cut the whole big steel ring, and then I'll take that big steel ring inside. I can screw it down from the center if I want it. I can still use that center tap. Give it a whirl, and we'll be laughing. Let's try this out in real world here. Okay, drill tap combo. Probably one of the best tools I've used making a hole. That's it. Now we start cutting. Well, that was beautiful. So that piece of angle iron was probably one of the best things that I kind of dreamt up. Making myself a circle jig meant consistent results. And I think this has cooled down. Still a little bit warm. This is that really thick material that I was working with. I mean, the surface that I cut from is pretty clean. The blowout side, yeah, not so much. I wanted to try it just to see where it would be at. So my GoPro doesn't like working in the cold, I guess, but you haven't missed a whole lot. I've had the heavier steel ring just on the bench grinder, cleaning up the heavy burrs, and I've tried to put a taper on the edge too to accommodate a nice weld when I finally get to that point. But you can see when this sits on the outer race of the bearing, it's going to be just the right size to be able to weld around the entire perimeter and lock that thing into place. What I still have to work on is clearing out the inner dimension of it. I didn't quite cut. Obviously, a plasma cutter is not a high precision cutting tool, or at least the way I used it, it wasn't. It's close. You know, it's very close, but it's not quite perfect, so I do have to do a little bit of cleaning and whatnot to get this to seat properly. And I have a limited access to tools, at least right now, because everything's closed, and wanting to avoid going to the store to buy something that may be unnecessary. I got my old drill press, and then my dad lent me his. It's a lot nicer. It has a bit more power too. Anyways, I'm going to use his because right now it's got the light, and that's what I want, to be able to see what I'm doing. And I've got this stone grinding disc, or this stone grinder, and that's going to kind of help me with the inside dimension on that steel. Now the thinner steel rings should be a little easier to work. This heavier one will be a little bit more labor intensive, but I'm going to spin those right now, or spin it right now on the drill press, and see if we can't make everybody fit and happy and start working. Well, it took a lot of finessing, but I was able to finally get that fitting. And based on the light transmission through there, which I think you guys can see pretty well, I don't think it turned out all that bad. I gotta say, I'm pleased with it. It's tight. I have to hammer it into position, but I'm absolutely okay with that. That's probably the best option anyways, because then we know for sure that this thing's gonna be definitely solid mounted. So I have the thinner washers to work on, which I figure at this rate will be a treat, considering how little material there is to work with there. So I'll try to tear through those pretty quickly, and then we'll move on to the next step. And then we got to get the welder out at that point. So. Alright, so I welded the first ball bearing back into the old race on the busted bearing, let's say. Now I'm going to kind of show you guys what the rest of my plan entails here. So I lay all the ball bearings inside the raceway. I got to be careful because this thing's about 1,000,000 degrees right now. Here's the cool part about this whole system. The way that the ball bearing goes together and the way that it broke gives me a bit of an advantage to kind of just drop them into place. I'm gonna use gloves. Call me a chicken, but so 1, 2, 3, 4, 5, 6, 7, 8. That's how many ball bearings were originally in this thing before the explosion. Now I get to space them out however I see fit, and then weld each ball bearing to the center and to the outer raceway. And that is hopefully going to add enough strength to this thing to kind of keep it in shape and not have it explode. I mean, time will tell, of course. I'm definitely going to focus a little extra attention near the broke areas there, but I think this will kind of be the gist of what I'm going to space it out as. I'll split the difference here. Some of these just want to roll away because, well, obviously you can imagine this thing's not like perfectly true anymore. But once all 8 ball bearings are welded and in position where I want them, that's where these guys come into play. Now I have to check on the machine to make sure that this is going to add up properly. I just need to double check that I've got enough clearance. But then I hammer on my steel plates on both ends and weld the steel plate to the center collar and to the outer rim, basically encasing all of this area in steel. And that's kind of the long-term intention here, is to just make this thing one solid chunk of metal, and this will be a point at which the pin in the back of the arm is going to pivot on. I know that you're going to say, oh, it's going to wear out and break and everything, yada yada. It might, yeah. I am planning to grease it, and I'm also planning to basically drill a clearance hole and add a grease nipple to this, so that way I can grease the inside center pin area using my grease gun, and hopefully that's going to be enough to just get us by and have this thing at least work. I mean, really, the bearing's garbage, right? It blew up. It's totally junk. So just doing this, the only thing I'm really wasting is my time. But yeah, let's go from there and see what we get. So this is going to be considered night 2. Last night, I got the bearing body welded back together and started welding all the ball bearings into position. I have to work on the back side of it this time and get everybody tied in and tight so they can't run away on me. I've got a lot of spatter that needs to be cleaned off. That's going to let my big rings get welded back into place there. Maybe I'll put the big one where the big chunk's missing there. Anyways, I'm going to fire this welder up, make a bit of heat out here tonight. It should be a little more tolerable then. Alright, I just ran the wire wheel and then my sanding disc on there, and it looks a lot cleaner now. Of course, my welds are not like 100% professional. As we know, we've been through this before, I am not a welder. Where I think this thing is really going to shine is, it's kind of interesting, is when I get this larger steel ring on there. That's going to take up quite a bit of space there, and should really add some rigidity to this whole thing and strengthen it up. So this is the top half, the thinner half. It's made out of 2 layers of the thinner sheet, which is right here actually. So it's got a bit of thickness to it, but it's, anyway, it's something. And then the back side, which is a lot less beautiful, is the piece that's made out of that giant plate-like product. So essentially what I've got now is a giant bushing, and this sucker weighs a ton now. So we're going to have to see how this fits on the machine. Hopefully it's going to slide into the recess and clearance and fit nice. I might have to use the sander and just tidy up the edge a little bit, which I'm totally good with doing that. I have no issues at all if that's what needs to be done. Pending the fitment of it, I'd like to also fill this void with something, maybe some steel perhaps, kind of clean it out a little bit, try to at least, see what I can come up with, if anything at all. But once I get that fit in the post that's under there, the peg or whatever you want to call it. Well, we've got a little bit of daylight here. And at this point now, I'm ready to test fit my Franken bearing, or Franken bushing, however you want to call it. I think Franken bushing is not a bad term. Wish me luck. Okay, so that fits over the Stem not so bad. Well, I've decided. I think we're just gonna send it, see what happens. Because if this breaks, I'm not really any further behind than I already was. So let's hope that this yields some positive results. That's about all of 3 tons that I can give her before I break this jack. I see threads. I'm gonna run that nut on and we're gonna see if what happens. Also, based on that quick little test, I think I can actually give this thing a shot in the real world with work and see if I'm gonna have any bit of luck keeping this thing running now, not blowing up. It looked like, I mean, I'm only watching this back on the GoPro, but to me it looked like the full bushing that I kind of welded up is stuffed up inside the cavity and the center pin is rotating, which is what I was hoping to happen. I did pump a lot of grease onto that pin or the spindle or whatever before I pushed the bearing, the bushing up in place. And I think there's enough of a space where I can still get some more in there when the time is right, when it's time to re-grease that. And I don't want to make it tight because I'm thinking that it's just going to want to shear and break off. So with regard to all this stuff, this is going to be the real test. I don't even know if I'll be able to drive back here today because it's so soft. I mean, I've already ruined the yard, so what's the difference in reality? But basically, if I can use maybe the front bucket from the driveway side and push my way in, I can start getting this stuff kind of tumbling into the hole. And I can probably drive on top of this to some extent. What a mess. And then I'm gonna have to order some gravel. Lots and lots of gravel. I should check out that coolant leak while I'm right here too, and the machine's not that warm yet, because that'll be something I have to address sooner rather than later. I'll check that out maybe right now and see what's up.